What happens when you drop an M&M into water? The answer is unexpected, a stunning display of color as the M&M turns into a shell of itself. Let's first try to understand why the coating seemingly vanished. The M&Ms are coated with food coloring and sugar. Both of these molecules are polar, meaning that they have slightly positive and negative areas. The water molecules are also polar. The water can easily attract and surround the similar coating molecules, allowing them to dissolve in the water. But why did it spread out? The spread of M&M food coloring is an example of diffusion. In diffusion, without any outside influence, a substance moves from areas with high amounts of it to areas with low amounts. This happens a lot in real-world situations. If you've ever smelled food from the other side of a room, you can think diffusion. While the water looks like it's not moving, the individual molecules are bouncing around randomly on a microscopic scale. This causes diffusion. On a higher level, however, diffusion seems ordered. Here's a graph of the area of the dye at various times during the experiment. It's nearly linear, which means that the diffusion occurs at a constant rate. Theoretical equations support this result, specifically Fick's laws. I also extended this experiment to examine the effect of temperature on diffusion. The dye and water particles move more quickly as you increase temperature. So, that suggests that hot water would have a higher rate of diffusion than cold water. This is what happened. The dye diffused around 3 times faster in hot water compared to cold water. In short, diffusion is an interesting phenomenon that we encounter almost every day. It's amazingly regular, yet random. If you can, you should try this out at home with more than one M&M and see what patterns you can get. Feel free to leave a like or subscribe if you enjoyed. Thanks for watching, and we'll see you next time.